Yeah, nice. Okay. This is all we did last class. Okay, it's kind of cool. I like it because the whiteboard doesn't go away; it's always there. Must have figured out a really nice compression scheme, I guess. All right. Okay, so what do you guys want me to do today? I mean, do we do? Well, it's entirely up to you, right? Because you guys are here now in class.
If you wanted, I feel like if you just went over a couple conversions really quickly, that'd be pretty.
Sure. I'm happy to do that. Why don't you guys? How do I unshare the screen? Oh, there is a stop share at the top. Okay, that's good. All right. So yeah, absolutely. You guys are running the meeting effectively. So you pick some numbers that you want to translate or convert from one base to another. Any base to any base. Okay. Any base meaning not 1, 2, 8, 7, 6. No, I'm talking, or even 27, right? Pick any base. Base 256 is fine. Actually, base 256 is the easiest possible thing you can do, right? Because in base 256, all you have to do is convert it into binary form and then chop it up into 8. And each 8-bit chunk is basically a 256 base character, a single character. Yeah. Do you know what I mean? Is everybody clear with what I'm saying, what I just said? Because it's a very subtle point, but it's important to know because if you take yes. I mean, if you don't want me to talk about it, that's fine. But essentially, you can think of base, a binary number in 8 bits, right? 8 bits. You can think of those 8 lines as the lines you're using to draw this weird character in base 256, right? So you have a number system in base 256. So, in 10, you have to, after 9, you go to 10, yes? But in base 256, you'd only go to 10 after 255. Yeah, and you can actually work it out on a piece of paper, right? I mean, you'll see that, right? So the 255, the character 255, you draw it. How do you draw character 255 in base 256? And can someone write it? Can someone write it down in the chat window? How do you draw number 255 in base 256? Okay, so let me see. I gotta share the screen again. Okay. I wish it's easy to just swap from here to there. Right? So here, if I, oh my God. Okay, in base 10, right? You go 0.9 and then goes to 10. Okay, base 8, okay, 0.7, and then the next number is 10. Yeah, so 10 in different forms. It's not 10, it's 10. Okay, base 16. Okay, 0. What? F, thank you. Someone spoke, but their volume is so it's like a mouse in a corner. So you gotta up your volume a bit or speak closer to the microphone. But I did hear you, but it's very faint. Okay, so after F you go to 10. Okay, base 256. Okay, 0. What? So I gotta have a funny character, right? I gotta have a character, a symbol that represents number 255. Maybe I come up with I'm very creative and I come up with the symbol, right? And I come up with the symbol like that, okay? All right, I'll be lucky if I can reproduce it 2 times, but maybe I design a character, an entire, right, 0 to 2, and that is 0 to 255. But fortunately, you don't have to do that. There is an easier symbol you can use that you have been using, right, in your mind anyway, all along, to represent the character 255. Can someone tell me what that character is? All right, what is the character that we've used?
You can use the binary 8-bit.
Yeah, thank you so much. I don't know who that is. I think it's all right, a Forrest or Andy or someone, right? So that character, sorry, who is it?
This is Andrew.
Andrew, yes, thank you, Andrew. Okay, so that character is basically this. That is that character. Because after that character, what do you get? You get 1, 0. Okay, so you get 1, and then this is 0. Okay, 0 is this character. Have I got 8 there?
Yes.
Yeah, okay, 8, right? So 1, 0, there you go, 1, 0. That's 1, 0 in base 256. Yeah? Everybody okay with that? Okay, so let me know what you would like to talk about, a particular conversion. Where's my chat window? Needs to be here. Oh, when I go to screen share, my chat window, it goes to the background. So I think what I need to do is basically not do full screen, on this screen at least anyway. So my chat window can be on the side. Yeah, thank you. That was Daniel. Yeah, okay, thank you, Daniel. Okay, so yeah, don't talk about quests here, okay? Well, unless we happen to digress into it in class and it's related, don't ask about having problems with quest and all. Okay, so that is all supposed to be done in your own time. There's a reason it's called homework. Well, actually now everything is homework, right? You can't go to class. Everything you do is really homework. Yeah, you can't talk about quests here. Because as it is, we have a lot of stuff to talk about. I got so many stories to tell you. All right, so give me some numbers, okay? Or think about, confer amongst yourself, right? Confer. You can confer in the chat window. I'm not going to interrupt, okay? Confer amongst yourselves in the chat window, right? Talk to each other and find out what you would like to do in class. Well, let's set a time limit so that we know for sure that we will start coding, right? Let's say at 9:15. Okay, so 9:15. That's a whole hour. No. Okay, let's say at 8:45. Okay, 8:45 we start coding. Then you get an whole hour to code. Okay, and so let's see. You got 8:45. You got a half hour. So confer in the Zoom window. Hexadecimal multiplication. I'm not going to do hexadecimal multiplication. You can do it, right? How do you do hexadecimal multiplication, right? So if I say 3A2 times, let's say B, okay? Yeah, so who's that? Who asked me? Forrest, okay? So I'm not gonna ask you to multiply 2 hexadecimal digits in the exam or quizzes, because ultimately you just need to know how to do it. You need to know how to do it in decimal. You need to know, you know how to do it everywhere, okay? So, so as long as you understand the principles, that's fine. Okay, so but in any case, how do you do this, right? So what you need to do is do B times 2. What the hell happened here? I accidentally scrolled up. That's funny. Well, I'm glad it happened in the first class, so I know what to do. So yeah, it's funny, isn't it? It's an interface issue. So when I use a pencil, if my wrist accidentally hits the scroll bar side, didn't happen. Something happened, something happened to basically scroll this all the way to the top, and I'm thinking that would be pretty disastrous to happen towards the end of the quarter, right? So we have like 50,000 pages of scribblings, and then it scrolled all the way to the top, and I got to figure out. Well, in that case, yeah, it should be like Google Docs, right? So you can always write at the top, and the bottom scrolls down. So you can't do that in a graphic, in a bitmap thing like this. Can you? No. Can you do this? No, it's all basically stuck to the paper. It's just one big bitmap. Yeah. It'd be really cool if a product like Google Drive, right? Google Docs or Microsoft Word that you can run on your iPad. Yeah, how would they do that? How would they do the, yeah. I guess they'd just have, they let you insert a square frame inside of which you can draw. And you can push it down when you scroll on the top. Yeah, this is 100 million different ways to do this, I guess. Okay, so where are we going with this? Yeah, okay. So we want to multiply 3A2 and B, right? So it's very straightforward and easy. Yeah, you have to discard overflow. No. So, right, so, and it's a good question, James. Yeah, it's a good question. Do you discard overflow when dealing with multiplication, right? Now, this whole concept of overflow, it does not even exist in mathematics, okay? I think that's a very important thing to keep in mind. In mathematics, in the math of it, in the underlying theory, there is no concept of overflow. And you just multiply. I give you a billion digit numbers, you'd multiply them. You can, and you get, oh, here's this number that's got a billion squared digits. There's no overflow. Okay, overflow is only relevant when you're dealing with finite media, right? Because if I have an, if I can't see the ocean overflows, the ocean never overflows, right? It's infinite, infinite. But you know what I mean, right? So overflow is only a concern when you're dealing with finite containers. Then so yeah, when you're multiplying, there's no overflow. But when I take the results of the multiplication and I need to fit it in a box, fit it in, some fixed number of bytes, then I have overflow, right? So overflow is a problem because it reduces the number of things you could possibly represent, right? But the genius of computer science, like we saw last class, is that we figured out a way to turn that handicap into our advantage. Took the lemons and turned them into lemonade. So that's how we use the overflow and say that it's really not a disadvantage, but we'll use that to make twos complement. Okay, all right. OneNote was really good and free. Yeah, maybe I'll give it a try that. Yeah, I used to use GoodNotes a long time ago, right? But anyway, I am in the frame of mind where I don't want to install a new app unless I really, really am forced to, right? Because I've been through a phase when I had so many apps and then I color-coded the apps into these folders. At the end, then I figured, it's all the same. You run into this, right? When you buy a brand new computer when you're a kid, you waste a lot of time just customizing it. Like MySpace, that was the death of MySpace, really, because people were spending a lot of time customizing their profiles rather than creating useful content, which is what, makes Facebook successful, right? And so, during my early days of using computers, I spent a lot of time customizing my computer, right? I have some weird key combinations or gestures that only work for me and nobody else. And then after a while, and I think that really was because the first computer I got, I thought that was my only computer because, it was like a game changer for me. And I thought, well, I've got the love of my life, really, right? Almost the love of my life, right? So I'm going to stick with this for the rest of my life. So I better customize it to the best possible, as much as I want. So I went and customized it. And then, after that, you realize, it's not that particular computer itself that you love. Right? Just like people, right? So in the beginning, you fall in love with the facade, the outside, right? But after a while, the facade disappears. You don't see the outside at all. What you see is the inside, and then you realize, I got to switch the computer, man. This computer is too old. It doesn't do it doesn't compile this 10,000 line code, program. You upgrade your computer. You can't do VR and things like that. Then you realize every time you upgrade the computer, you got to re-customize it, especially even with operating systems like Linux, right? So you can create a package of binaries that goes with you. But if you have too many of those, you end up in a mess. And then you realize that, the easiest way to navigate this, this ocean of computing really is not to keep customizing every step that you land on, but basically just learn to love what it is. So then the facade ceases to matter. And then you say, well, I don't want to customize it. I don't want to customize it because if I customize it, I can't move on to the next one. So, and then you say, no, I'm just going to take what's there and do the minimal amount of customization. That's why, yeah, I try. I think I still have GoodNotes. I just don't use it. But, I have all the standard stuff, like Word and the Office and stuff, Office and Apple apps. So I'm happy to customize those things a little bit. Okay, so yeah, B times 2. What is B times 2? What is B? 11, 12, right? So 12, 24. 24 in hexadecimal would be, oh, wow. Anyways, it's going to be 8 ones and 116, right? So I got 116, okay? 116 and 8 ones. That is, that's 0x24, okay, and that's not 0 times 24, okay, that's that's octal. Geez, okay, 0x 18 equals decimal 24, yeah. Okay, so what we want to do is I got 18 in base decimal, so in hexadecimal, so I say 8. Why is this keep switching off to erasure? Okay, so and I carry the 1. Okay, B times A, well, I'm not going to do that for you. But, you know, B squared, this 12 squared is 144. So B times A should be 144 minus 12. That's 132. And, you know, 132, I don't know, maybe it's even divisible by 18, 16. I don't know. You can do this on your own. Okay. Is everybody okay with that? This is how you do hexadecimal multiplication, right? And in fact, you'd be surprised. This is how you do, you know, you can actually do base 256 multiplication too, you know, or if some aliens with, you know, or some millipedes, right? Millipedes become intelligent in the distant future, and they come up with a number system saying, oh, we, you know, you puny humans, you only have base 10, but, you know, we millipedes have, you know, we operate in base million. Okay, a base million. Actually, a millipede doesn't have a million legs, but you know they could potentially be operating in a base million and say, well, you know, you can't multiply 2 of our numbers. You can multiply 2 of your numbers. You can multiply because you're base 10 guys, but we're base million millipedes. Okay, but you can say, hey, no, that's not the case because although we only work with base 10, we know how to do your stuff too, right? We just don't do it because you know we don't care about a million feet, but we know how to do it. That's the important thing. And the millipede will say, yes, yes, thank you, boss. Okay, so you're the king. All right, if that matters to you. So everybody okay with that? Yeah, okay, so that's what you got. All right, so do you guys want to do conversions or are you guys solid on conversions? You know, base, you know, going from base, that's multiplication hexadecimal, you know, and you know how to convert from binary to decimal and things like that too, I hope, right? This is very straightforward. I've seen, you know, stuck a couple of videos on YouTube. It's linked to our nonlinear media channel too. So you should be able to pick up those things and go through that. Okay. So what do you want to do? You know, I mean, we'll be perfectly fine starting to code at 8:45. You know, this is a bunch of, we're just going to play around. You know, we're going to fire up a computer, a compiler, and then go around, go into the compiler and play around. You know, I don't have a fixed agenda for exactly what we're going to code. We'll just code what you guys want to code, you know, and people can call out. But if you don't, I'll just say, well, let's try this. Let's try this. You know, let's try the plus plus operator. Let's try some different groupings using parentheses, right? Let's try, you know, or even, you know, we can use the compiler, or, you know, we can use this IDE to convert. Yeah, we can try that. All right, and try to convert from, yeah, actually, why don't we do this? Right? Not hexadecimal. All right, let's try and do something easy. Easy meaning you can do this in class. Let's try and convert a binary number to decimal. Okay? Let's try and convert a binary number to decimal. You know, you got to be, you shouldn't, there's an easy way, right? You can always tell the compiler, or you can tell C++ that, hey, I want to print this number out in binary. And then you can say, you know, I'm going to use printf of some, you know, output manipulation to tell the compiler to print out this quantity in binary. Okay, that way you can do it. You know, you can just say, you know, print this number out, this quantity, 75, 86, whatever it is, print out, but not in decimal. Print it out in hexadecimal. Okay, but you can do that. So so there is a command called printf. Okay, this is also a command. It's a function, not function called printf in C++ and C. Also Java, and believe it or not, even Python now. Printf is such a useful function, you know, it was part of C. But then, interesting history, right? Anybody want to listen to this or no? Yes, okay, thank you. All right, interesting history. Because, you know, in C, you have this printf function, which lets you do really nice formatting. Okay, suppose I want to print pi, right? Pi to 7 decimal places. Okay, 7 decimal places. Now, in C++, you can do it. Everything is possible, right? In C++, everything you can do in C, you can do in C++ too. Because C++ is really a superset of C, right? It has everything that C has, and then they added on. Actually, you know, interestingly enough, more than they added on to C, what they did in C++ was took C and said, I'm going to take off, right? So C gives you the full power of the computer. And then in C++, they said, well, you know, if I give people the full power of computers, most of them are going and shooting themselves in the foot, right? Because, right? And so what I'm going to do is take the power of C and then and then make it much harder for people to use these really dangerous things, okay? So it's possible to do everything in C++ because, you know, it is a subset of C, but, you know, they took away some of the freedoms, right? But not took away, you know, took it away and put it in a cellar, and locked the cellar, and took the key, and they put it there, you know, right in front of you. So if you really want to use the C functions, you can take the key, you know, you open the cellar, take the function and use it. They just made it hard. The idea behind that is not to say that you guys shouldn't use these C functions, but, you know, but really they're trying to say that, you know, it's there for you if you want it, but, you know, better be sure you know what you're doing before you go in there, because that cellar is full of dark beasts, okay? So that can really bite you. So you got to be careful. So printf is a C function. It used to be around for a long time. And in C, you can actually, where the hell did my pencil go? Oh, it's right here. Okay, so in C, you can, oh wow, the keyboard popped up as soon as I hit the pencil. If I, you know, I didn't touch the screen and the keyboard popped up, which actually, I don't know if it's a good decision, right? Because you only need the keyboard if you're typing, and then with typing, you don't do it with a pencil usually. You can type with a pencil, right? So if I take the pencil, the keyboard should disappear. Okay, so printf, right? So in cout, you do something like cout, and then in C++, right? The traditional way is to say, you know, I think it's, you know, precision or set, oh, maybe it's set precision. I don't know, I got to look up the syntax. You know, I forget, you know, most of the time, you'll also find out, right? So later on, you'll find out that a lot of things you remember now, like C++ formats, you'll forget, because there's a lot more interesting and useful information that you have to remember. And then these things you know for sure. You won't forget it if you know that you can't look it up. Yes? You only forget things that you know for sure that, you know, I know how it works and I know it is correct, but I don't have to remember it because I know you can always go back there and find it. Yeah. So it's interestingly enough, you know, when I was a grad student, my first PhD, well, I don't have lots of PhDs, right? My first unsuccessful PhD, right? So I enrolled in a PhD and then I changed subjects after a while. But initially I was trying to do PhD, you know, a doctorate in back in the day in human-computer interface, right? So human-computer interaction, HCI. And so what I wanted to do was, me and my advisor, right, was to make Unix, which we thought was really, really powerful operating system, right? So it does lots of beautiful things, but we wanted to make it beginner friendly. Right, so because, you know, Unix is so powerful, but a lot of beginners don't know how to handle Unix or Linux, right? So, and you know, actually, if you look at it, you have Mac OS on Apple machines. It's just that it is basically Unix taken with a GUI, you know, like, you know, Ubuntu and so on, right? It's a GUI slapped on top of that, so it's easier for you know, beginners to use. But if you really want the power of Unix, you can go under the covers and get a terminal. And you can, you know, drive the Mac like as though you were root, right? And Windows too, right? Even in Windows with the latest release, Windows 10, I believe you can get a full-fledged Linux terminal now. You don't have to go through the pain of installing Cygwin, which I always hated, right? No, I didn't hate Cygwin, but I hated the process that, you know, I get a Windows computer, which is so beautiful, and, you know, but in order to get to a powerful command line and not have to use DOS, you know, which was great for its time, but you know, you have to install Cygwin, and it's not native, and it's a pain. But now it's all native and it's built in. It's kind of cool. But anyway, so Linux is so powerful, and but it's not beginner friendly. So we wanted to find out how can we make Linux beginner friendly, okay? And obviously we're not talking about slapping a GUI on that, because, you know, if you slap a GUI on that, you basically get a Mac, right? But we wanted to make a command line interface for Linux, right? So where's the command line interface? Let me, can I share my, oh, here, my screen. Jeez. Oh, this keyboard. Oh, gee, you know what? It's crazy. I got to figure out. Or maybe I just got to get used to it. So this magic keyboard is attached to this computer, right? But I need to type on the laptop, and then I need to use that keyboard and, you know, hunch over like that. It's just a pain. You know, but the interesting thing is using today's technology, today's software, it's actually possible, right? It's built it into the operating system that, you know, this camera, well, you know, they have Siri, they're doing acoustic processing all the time. I can say, hey, Siri. Well, he didn't listen to me this time, but the camera is, the microphone is listening all the time. And what happened? Okay, right? Is listening all the time. So likewise, they can also have a video feed that's constantly monitoring. So if I have a magic keyboard and I lift it up, that should be easily recognizable. A couple of hours of training data, I think it should be possible. So as soon as I lift it up, they should have a picture of me, the camera feed on the screen with a virtual keyboard under my hands, so that I can look at it and say, well, I want to push the keyboard to this side, bam. And then automatically the Bluetooth and everything adjusts so the keyboard is now associated with the new computer, right? And you lift it up and push it over here or something, some other gesture, you can discover through focus groups. But it should be possible. Now I got to bend over, okay, and use this thing here. Okay. What was I trying to do? Oh yeah. Terminal. I'm going to stop share here and let me open up a terminal. Okay. So that's. Oh, I got to share the screen. Okay. Share screen. I want to share terminal. Oh, there you go. That's cool. Okay. So that is my. Can you all see the screen? Okay. So that is my computer. Right. My terminal, and I can actually run C++ programs here. Right. So yeah. In fact, let's do it really quickly now. So I can go to a temporary directory. It's temp because I don't care. We shouldn't, I don't want to save it. So let's just create a very, very simple C++ program right there in this temp directory. And I'm going to compile it and run it, and I'll show you, right? So you don't have to do it this way. I don't do it this way, really. I'm only doing it for class, okay? So I'm going to call it main.cpp, all right? I'll say main.cpp, all right? And then I say hash include IOStream. Okay. Oh, maybe we'll talk about all these things, right? Hash include and using namespace. Okay. Later on today, after we're done with these conversions. Okay. Into main. Yeah. Okay. Let's not take any parameters now. Right. Ah, damn. Okay. All right. Okay. I can't do the entire thing like that. I got to go into an editor. Okay. So I say cout. I could have done it, if I hadn't hit enter and the brace, I could have done it, right? I got to bend forward and it's messing with my, Okay, all right. So I have this compiler, this program that I just created. Cat on Unix is basically, right, is type the contents out. Now I want to compile that program, right? I want to make it clean, even though it's okay. All right. So this is the program. I want to compile it on a Linux machine, or Cygwin or something like that. If you have G++ installed, which I think is default now, right? So -O meaning I want to compile the program and create the compiled code. The binary that the CPU now exists. Look at that, right? This program that I just wrote is a program very much like in English. Can you all see the screen? Can you see my terminal? Yeah?
Yes.
Okay, great. Okay, so yeah, this program is written in a very English-like language. Hello world and main. So you can look at it, and provided you know C++, which is not all that different from English, right? What I mean is that, compared to assembler and machine language, it's not all that different from English, right? So you can read it, you can understand what's going on, you can follow the logic here, yes? But once it's been translated, it's easy for us to follow the logic, but there's no way, absolutely no way well, there is a way, but it's going to be painful and slow and useless, really, for all practical purposes. The computer, the CPU, the chip inside cannot understand that language, right? So for it to understand this language, this instruction, these things here, the program that I wrote, need to be translated to a language that the CPU can understand. And the CPU can only understand a language that is composed of 2 letters, ones and zeros, okay? And I'll show you, right? I'll show you. We're going to compile this program, and then this command that I'm typing here, okay, main.cpp, right? This program, G++ is a program. In fact, you can say, right? So I can say, show me, where is that program, right? User bin G++, okay? This program is a C++ compiler, and the compiler, this program is only 18,000 bytes big. Okay, this program, the C++ compiler you're using the program that is responsible for reading your program and converting that into another program that the computer can understand. Okay, so that itself is a program, which means that this compiler had to be bootstrapped. Bootstrapped is when you start from nothing at all, right? So, and how was G++ written? Right? If you look at how G++ is written, it's actually very interesting because, you know, to create G++, they actually started to build a C++ compiler, a very bare bones G++ compiler, which can do, you know, you bugger all, you know, very little. And they used that compiler to compile a better version of itself. That bigger compiler can compile a bit more C++, a bit more C++, right? So the compiler itself compiled itself. Okay, so it's incredible, isn't it? So that's a bootstrapping. So G++, this program is going to take my main.cpp, that program that I just created, and convert it into all binary. Okay, so that command will do it. Now, you know, you don't have to type out that command. If you're on a Linux or Unix terminal, you can actually basically say make main. Okay, make main. Make also is a program, right? Which main? Okay, so you can see which main. So oh, it's built in? Oh, damn. What was I going for? What was I looking for? Make. Yeah, okay. User bin make, okay. So it's, yeah. So it's, and that again is a, let's see how big that program is, okay? See, that program is, how come they're all the same size? Okay, maybe they're all just wrappers, okay? Wrappers for some other binary. So yeah, maybe I got to take that back. Okay, so so the compiler will probably fire up other programs to do the actual compilation, right? And this wrapper that combines, oh, unless it's, yeah, okay, this wrapper program that invokes all these other programs for you, that's about 18,000 bytes. Okay. So anyway, so I need to say make main, okay? And you'll see that is actually running the same command. Well, it's running C++, but I'm pretty sure you can write, you know, G++ pretty much. G++ is the free version of C++, right? Right. So it compiled it and it produced a program called main, right? ls-n. So that program, if I run it, main, okay? And then it's in the current directory, so /, you know, it's in my path. So if I run it, it's going to say, hello world. Okay, so we just wrote our first program. We created, you know, a binary version of it, and we ran it. Now, what's inside of that program? We know that, you know, cat main.cpp has the English version of the program, but what is inside the computer version of this program? So so you want to see the code that the computer, the CPU understands. Can you see it? Okay, let's take a look. We're going to cat is concatenate, right? Concatenate meaning, you know, take the contents and dump it, concatenate it onto the terminal. It's called concatenate because, you know, in those days, you know, we just dumped something on the screen and then dumped something else on the screen. Essentially, they're all getting concatenated one below the other. The screen is one endless, long scrolling page, which is really what I have on my iPad and all these, you know, this terminal too, right? So you concatenate more and more stuff to the screen. That's why it's called cat. Okay, so cat main, I hope this doesn't screw up my terminal settings, but if it does, we'll kill the terminal and start a new terminal. Okay, so here you go. I'm going to hit return. You know, actually, I do the safer thing here. Okay, -v. Okay, so -v means don't print all the special characters raw, right? Just make them more visible, like, you know, visible ASCII characters. So if I have a control X or control D, right? If I send a control D, control D is ASCII 4, A, B, C, D, right? So control D, the terminal won't intercept the control D, and you know, it won't do funky things. Maybe that control character is a signal to this terminal that says, you know, turn the background white, you know, turn the background green or something like that. So I don't want to mess up my screen. So I want to make all the funny characters. Because, you know, in data, you don't have only ASCII characters, right? In data, you have everything. You have numbers, you have, you know, all your pictures and all these things. So instructions, the CPU instructions, they're not restricted to just the ASCII bytes. They could be anything, you know, 1, 2, 3, binary, 1, 2, any of those, right? So if I cat this, you'll see a whole lot of junky characters come up on screen, okay? There you go. So, and see the control @ is essentially 0, the byte 0, right? And control, you know, control A will show up as 1. This is a control G, right? Control G is actually binary 7, right? And you can see that. I think there is a program called OD is octal dump. Okay, OD-X means dump the contents on screen, except not in octal but in hexadecimal. -X is hexadecimal, right? So if I say OD-X main, okay, so now you can see that those are the contents of the program. So that you know, FA, that's the first byte. CF, that's the second byte. And these are the addresses of the, you know, where the relative addresses. So can you guys see it now? It's that is the binary program. That is the program the CPU actually sees. That is what gets loaded into memory, and the CPU gets a signal saying, hey, I've loaded a program for you in memory location, blah, blah, blah. You go ahead and read all those instructions one by one and start executing them, right? So that's what the CPU sees. It doesn't see main as pretty hash include, right? It doesn't see any of that. It actually sees this. So anyway, you know, we're talking about printf. Okay, all right, let me stop the screen share. By the way, you know, I mean, you guys should, like I said, again, I have to keep reminding you all the time. If you think that I'm digressing too much and it's not useful, interesting information, you got to haul my ass back in line. Okay, say, we got other useful stuff to talk about today on, so just go ahead and, you know, talk about useful. Always. All right, so printf, that's how we used to do it. Share screen. My bad. Okay. All right. So yeah. So if I wanted to do see how, and I have to do something like, you know, set precision. Yeah, I know where we were going with this. This is yeah, when I was in my trying to do Linux, make the user interface for Linux easier for beginners, right? And so we wanted to know what differentiates a beginner from an expert, because, you know, during the early stages of using an operating system or any product, you want a lot of help. You know, people need to tell you, do this, do this, do this. But as you get more and more expertise with a computer, with the operating system, with a command line, this extra help, this, you know, with people saying, do this, do this, do this, becomes more of a bother. Right? You just want to go. That's why people, you know, once you get experience, you prefer the command line many times, right? Not always. So because it gets things done faster, right? Because you don't have people help all the time. Like, you know, there was you know, Seinfeld, I think, a long time ago. He came on. It was an interview, and he made this joke. You know, when you're driving, when you're in a plane and the pilot is incessantly talking to you, saying, hey, now we're flying over the clouds. Now we're flying at, you know, 31,212 feet, right? Shit like that, even though it's not pi feet or something like that, nothing interesting, right? So, and he said, you know, why don't the pilots just do their job, you know, shut up their mouth and drive, you know, or drive the plane? Because, you know, how would they feel if I went into the cockpit every 5 minutes and say, hey, now I'm going to eat this peanut, right? Okay. So like that. When we get experience with something and you want to get the job done, you don't want the system to keep, you know, interrupting all the time. And so we wanted to know, what is it that distinguishes an expert from a novice, so that we can design an operating system that grows with the user. So in the beginning, the operating system is also like a novice, right? So, like a puppy and a kid, right? They're playing together, you know, they get older. So, right, and then when you get very experienced, the operating system does not give you as much help. It just lets you do the job and is in the background. It melts, it becomes, you know, dissolves into the air, as it were. It's invisible, but it's there. You feel the power, but you don't see it anymore, right? So that's, and so we did some research. And then one of the experiments was, you know, we decided, I think it was a reproduction of some other experiment we had read in the literature, and we found the same results, right? So we, because we had chess players in our college, and then we got an expert chess player, right? And then a total novice, right? It's a total noob, and then got them to play. And we did this with lots and lots of pairs, and, you know, and then we video recorded the game and also asked the two players to speak their thoughts, right? So in other words, they got to think and think aloud so that we can record the thoughts and then listen to their thoughts and look at them move and figure out, well, the expert is thinking like that and the novice is thinking like that. So, so that is what is missing, or, that's what needs to go from a novice environment to make the expert feel comfortable, right? So our hypothesis was that when you get to be an expert, you get to think really, really fast, like von Neumann, right? You think really, really fast so that, you have a configuration, a game configuration in chess, and you have to make a move. And then we figured an expert will be able to think through like, many different moves really, really quickly, right? They'll say, that pawn, if I move that pawn there, I'm going to get killed by the queen. Or, you think through all these moves and then make the best possible move, right? And then we figured the novice is probably not going to miss, the novice is going to miss like 90% of those moves, right? He's going to say, hey, if I move my little horsey guy over here, the chessboard looks really pretty. Let me do that, right? So, so that's what we figured novices do. They won't be able to think through all the moves. But then when we look at all the recordings consistent, right? Exactly the opposite. It's incredible, isn't it? Exactly the opposite. So when the novice is actually thinking through every single move, well, not all, obviously, but they're painstakingly thinking through all the moves, right? If I do this, they're going to do that or that or that. If they do this, and they're building out this tree of possible moves in their heads and thinking through all, and that's why they're taking such a long time, right? And then we figured the expert must also be thinking through all those moves, but really fast. But maybe they're doing it really fast. But so we asked them and said, no, we don't even think about those moves, right? So, but they are. This has all been relegated to their subconscious, right? So, and then we say, do you actually know these things? And then we found something really interesting. And the expert said, no. So many of these things we actually just look up. We know it's possible, but we just look up. We don't know, right? And that's what you find. And then suddenly it all hit, right? So in Unix, that's how it happens, right? So take a command like sort, right? Take a command like right? Sort, or any simple command, grab. So they have like a billion options, right? So like now, I used cat and G++, cat -v, something different, od-x, something different. So every command in Unix has a number of options which modify its behavior. Now, a beginner in Unix tends to memorize all those options, right? Say, I got to use grep-i there, right? Because if I use grep-v, it doesn't work. So they memorize all these little options, and then their mind is crammed with all these details, right? But when they get expertise, right, what they do is don't learn more things, but they select the parts of the knowledge that they've already learned, and they say, I don't need this anymore because I know where it is. I can look it up and jettison it, right? So maybe it's how children, right? So they remember a lot of facts. When you get older, you just remove a lot of things that you don't need because you make room for new things, but you don't remove things that are useful and you cannot get, right? So you need to know. I can get it back with a small amount of effort, right? If it's always a trade-off between the effort you have to put in to get something and the value of it, right? So if I can jettison something from my mind and I get it back really quickly, then I would jettison it. So that's basically what ends up happening. So how do we get talking about this? Okay, so so that's, I don't know. Maybe you won't know either, right? So there's some magic here. Okay, there's some magic here. You send some stuff to see out stream, like an escape character, and it'll intercept that, and then the stream will the see out, right? It'll reconfigure itself to print things differently, right? Maybe I say set position, 7, or using 7 decimal places. I don't know. Right? So forget that. So printf made it all very easy. I can say printf, well, it didn't make it all easy because this is the way it was. I can say percent is the escape for printf. I could say dot, I don't know, it's 7 dot, okay, 7.3 /n, new line, okay, comma pi, some variable that I have that stores the value of pi, right? So it's just a statement, the statement. So what that means is that print the value of pi, this variable pi, right, using 7 spaces, of which 3 are used for the decimals, How cool is that? This is really cool, isn't it? And and so, but the early C++ programmers said this is horrendous, ugly syntax, right? It's ugly. Yeah, maybe if on first presentations, the printf syntax looks ugly, until such time as you start using the other syntax, and then you realize, oh my God, for the last 5 years I've been using a syntax that's even uglier than this printf syntax, and I didn't bother to use that other one even though it was available, right? And so I think there was a time after period, when people started realizing that, let's not anger the people that use the C++ syntax, but we'll also make this common. And so people are, in fact, using. Thank you. Yeah. All right, Augie. Right. Yeah. Well, I'm sorry. I was just catching up on the chat window. The chat window disappeared, and then I had to scroll up. Let me actually make it bigger. Okay. Yeah. All right. So, okay. As I was saying, yeah, printf. So it started making come back. So a lot of people use printf, and I don't care. In your quests, for example, you can use printf if you want to have exact formatting. Just look it up, right? I think I saw a couple of messages on screen. Someone posted saying, "Hey, my answer is just different in just this one extra decimal space where there's a 0 and mine doesn't have a 0 or something like that." I don't know. I forgot. So use printf. You can look up set position and iOS position and things like that. You know how to do it in C++, but ultimately I think it's easy because it has to be easy because Java. Remember, right? Those of you who know Java, when Java started out, I don't believe it had printf. Right? It only had print, and then in Java print, it's I really hated using Java print, right? Because to concatenate two strings, you have to plus and it's horrendous syntax, right? In many ways, for maybe it's suitable for some things. And then all of a sudden I realized, I discovered that printf is available in Java, so they incorporated that into the Java language at some point. Maybe it wasn't made all that popular, but I discovered it's there. So I could actually use printf in Java too. So obviously it has value to it, right? Now I gather, in fact, I just realized, found out, I think over the summer when I was trying to do some Python code for something else, I found, because I didn't know, right? I didn't know that Python had it. The Python also, the Python 3 anyway. I don't think it's Python 3. Is that the latest version of Python? I don't know, right? So it has a printf-like output statement too. It's kind of cool. You use curly braces. Except I don't know if you can do digit formatting. Maybe there's a way, right? So you just look up all these things. Okay, so that's the interesting history of printf. Okay, so there you go. So you can do that. Where are we going with that? How did we get started talking about printf and printf? We're talking about something completely different. We're talking about hexadecimal multiplication, and then we started talking about printf. What's the difference between printf and cout? Oh yeah. Muhammad asked that question.
I hate to interrupt, but you said we were going to be encoding at like 8:45, and it's like 8:54 now.
Okay, all right. You want to start coding? Is everybody okay so far? All okay?
Yeah.
All right. Let's start coding. I'm not going to code on my iPad. Honestly, let me stop screen share here. And what I want to do is, wow, why is my battery at 15%? Oh, there you go. Okay, it wasn't plugged in. It wasn't plugged in overnight, maybe. All right. So what do we have here? So I want to open up a browser and share that screen. Do I do it here or here? Maybe I'll do it here. Okay. Yeah, I'll do it in this other screen so that I can have this thing to talk to. Let me go to a browser. And then I can share the browser. Yeah, okay. Let me try that. Browser. Oh, I gotta share the browser. Wait a sec. Okay, so I shared the browser from my other from the iMac. So can you guys see the browser now? It should say Zoom because it's that Zoom tab. Yeah.
Yeah.
Okay. All right. So I can go to, you know, um, um, repl.it, I guess, but I'm not going to do that now, but this is how you do it, right? So you go to repl.it and then you should be able to code and collaborate without friction. It seems like an awesome environment, and it's been there for at least 3 years now, I think, because I think someone brought it up. We never did it, but someone brought it up even 2 years ago, maybe 2 years ago, right? So let me just go ahead and do cpp.sh. Oops. Triple click is not working. Oh, geez. Okay. Oh, it's a funny thing, you know. This is fun. So I'm working on this computer here, right? This is my trackpad and keyboard are connected to this computer, and then I'm triple clicking on the URL bar, waiting for it to highlight. And thinking, why is it not why is triple click not working? But it turns out because my two screens are now identical, I'm sharing this screen with that screen, right? So I'm looking at this screen and trying to figure out this thing here, and obviously there's this lag, and it's a microscopic lag, but now you can see what the lag is because, and we're so spoiled, right, for instantaneous feedback from computers, right? So I'm triple clicking, and it takes like a half a second for the triple click to propagate to Zoom, the Zoom service in the cloud, and then Zoom to blast it out to broadcast it to all the computers that are listening, and then this computer is listening. So even though these two computers are side by side, what I do here, this doesn't know until it goes all the way into the cloud to Zoom, and then Zoom beams it through the NAT and through my router to this computer, and then there's this lag, and I'm triple clicking here, and it doesn't turn blue here, and I'm thinking it doesn't work. Okay, so here, this is where I should be looking, right? cpp.sh. Okay, so all right, so there you go. So if you do that, you should just basically come to the screen, right? Now, cpp.sh is a compiler. The reason I like this for classes like what we're doing now is mainly because it doesn't offer you all the really cool features, okay? All the really cool features that other places like Tutorials Point or Replete give you, which kind of forces you to not use it for big projects, right? Because really, for big projects, you only want to use the cloud to store your stuff, like Git or someplace in the cloud. Get an S3 bucket and stick your code there. Really, Git is good because it also does version control, right? So GitHub, not Git, right? So or you can sync your Git to your GitHub. Yeah. So what was it going there? Yeah. Okay. So use this thing because it forces you to keep your programs small, because there's really no cool way. Maybe there's no way at all to save a program and come back to it the next day. Well, you can do it. I'll show you, right? So I can say let me change this, otherwise it's not going to let me save it. Okay. All right. So or something like that. Okay. So if I run this, once I run it, okay, so it runs. Can you all see the screen? Okay. So now I can hit get URL. Okay. And then it gives me this short URL here. Now that URL I can bookmark. Okay. And come back next days, next week or anytime later. I don't know if they basically expire these things. Maybe I should go back to one of these URLs that I created. Like, I don't know if I recorded that. Or maybe I can look in one of those YouTube recordings on our channel from, 3 quarters ago. I don't know if they're still there. Yeah, maybe I'll try one of those URLs and see if they're, that way you can find out how long they keep your code, right? Because, these places don't give you any guarantees that will keep your code for you. Like if you go to Google Drive and create a document, you can have some kind of an assurance. Even though it's free, you get an assurance that they're going to keep it for you if you come back after 5 years, right? Or you get an email if they're going to expire it. But better yet, go to a paying service like, and then do that. Okay, so Forrest said something. Forrest said he uses the same shell every time. Is that right? Is that what you said? Why my chat window on the other side, and the other thing disappeared? Oh, is it because it's in a different screen?
But yeah, no, I was just saying, yeah, I use the same shell. I just keep it open as a tab online, and then it will never go away.
Oh, I see. Okay. Oh, cool. Yeah. But I kind of like, try and see if you can use Andy's solution for Replete, because who knows, right? It may be a good mirror for you to come back at the end of the quarter. Even better, do my 2B and 2C also, and then come back after you finish your 2C. Come back and look at the code that you saved in Replete or somewhere now, and then you can see. And then also remember, right? Add comments in your code before you say, put it in the background, put it in the back shelf, saying to give you some hints about how much you struggled and where you got stuck and so on. Because then after 5 quarters, you come back and read it, you will see how many of those struggles you actually forgot, and how many of those things you just do, without even thinking. You just go and say, I'm going to write this program, and you do it, and you don't know. You started and you finished, and you got this thing working, but you don't know how you got it right. But you can, but you just did it almost like an auto, a robot. Okay, so and now if I can go to cpp.sh and gives me this, if I just go, let's just go. This is a basic program. Okay, this is the basic program. This is how you start off. It gives you a shell, and you can code in there, and then these are the variables. Okay, this thing. You see, on my Mac, I can triple click and drag, so I can get the entire. Right. So see, if I triple click and drag, I can select multiple lines like that. But for some reason, it's not sticking. I got to press. I got to find out and go to the settings on this iMac. I only got this iMac like a couple of days before the class, our course started. And then, as you know, the iPad arrived much later. I didn't have it for the first class even. So I still have to figure out the settings. Every day when I log into this iMac, I get a little, prompt at the top that says, click this and get to know your iMac, And I always click later, tomorrow, remind me tomorrow. So I never actually got to know my iMac. This is there. Mainly because I find, I got to figure some way of making it more usable. All right. Okay. All right. Good. So we're coding right now. Okay, we're coding right now. You guys need to tell me what your struggles. Why I gotta stop the sharing on my screen here to get the chat. Okay, we'll leave this as we'll make this share the screen. I'll just do all my talking from here. I'll get my chat window up here. Okay. Chat window here. Why, all right, I'll push this thing over here. They shouldn't let the chat window. All right, I can see the chat window and the screen at the same time, and I hope that you guys also can do it, right? Because just some people are typing in the chat window, and I'm missing all of it, right? Maybe there's some exciting discussions going on here. Ty had a brain fart. Okay, all right, cool. All right. So you use it anytime you're entering an input for a variable for a program. I don't know what that is in the context of. It doesn't matter, right? And maybe something we're talking about at that time. Okay. Oh yeah. Okay. Yeah. Use it for getting input.
You're saying right here, like how you're putting in an input for name.
Yeah.
So it's basically just allowing you to say name then when you put it in, like you did down here for std count.
Yeah. That's kind of cool. Like again, here too, you can, in theory, use a C++. No, you can use a fallback and use a C version of reading input from the user. And like printf, that I think that function is called scanf, right? Scanf. And again, like printf, it has this documentation, lots and lots of nitty-gritty details about how to how to scan input. Anytime you want to know more about printf, you just go to Google. You can type it on a terminal too, right? You type man printf, right? Okay, all right. So you type man printf, okay, and you get these manual pages. I think it's 3, okay, not 1, because there's 2 different versions of printf, one for the shell and one for. All right, so there you go. So you get the synopsis, you get the meaning, this is the name of the function, and then how to use it, right? All of these things, and I bet you may even have some examples here, examples of using printf. Somewhere in there, okay? I'm not going to find it for you. Oh yeah, there you go. Okay, there's a whole bunch of examples. Hey, look, they also use pi. Did I use pi when we did that? Pi seems to be his favorite number, right? Everybody likes pi, all right? Whether it's apple pie or numerical pi, everybody likes pi. We're going to make pumpkin pie in a month from now. Yes? Okay. All right, great. That's printf, and obviously you can do scanf too. You can do scanf. You can just go here, say scanf, and you'll see it's almost exactly the same, except it's reading input from the user instead of writing. But don't use scanf. I think scanf is more painful. Plus, if you use scanf, you got this is the usage of scanf is a bit more subtle, and it's got more intricacies to it than printf. I mean, printf is brain dead. You basically just do this and scanf. So I think cin, like first Forest, was it Forest? Augie, yeah. Like Augie said, when you're taking input from the user, always use cin. But don't use, right? Don't use. Hey, did I have my shell? Oh, here it is. Okay, don't use this. Okay, so if I have int. Wow, why is this all indented? Okay, all right, so. Okay, so if I say int, yeah, you see, some of the advantages of using an IDE is they're like Xcode or Visual Studio. This formatting is, auto formatting is much better. Okay, so int x, or no, you never call an x. Here's the thing. I think I made this point in a previous lecture, not for our class, in a previous 2A lecture. You guys should feel free to look at previous CS2A lectures that I have recordings of. No, I don't. So when some of the students like you, right? They used to bring these iPhones and iPads to class, and some of them recorded the class and they posted it on our channel, Nonlinear Media. So you look at these, and I think maybe I don't know, maybe I talked about it, maybe I didn't, but really, if I had, there's some conventions here, right? So it's very important to follow convention when you're programming. Now, which is taking C++ as an example, and going back to what I was saying before, C++ is just C with a lot of stuff taken away, a lot of freedom taken away. Right? So, and you think that, well, what, C++ is supposed to be such a great language, but it doesn't give you all that freedom to do, be yourself, as it were. But there's a reason for it, right? This is a reason why people willingly gave up freedom, right? So it's important. And it's very important to keep in mind, not just in programming or anything, right? So it's not good when freedom is being taken away from you against your will. Right, so then it's like it's a slavery. It's backward. It's in the back in the day when humans hadn't really got in touch with their humanity. It's more savage than human, barbaric. Right. So no, we're not talking about that. We're talking about a civilized way of thinking about these things. Of freedom, and we live in a democracy here. In a free country, right? In a free country, we live in a democracy where we have willingly given up a lot of our freedom. Right, so I don't have the freedom to do a lot of things that annoy other people, right? So there's a law against these things, even though I'm not doing something outrageously illegal. But those are things that I willingly gave up. And I say, I'm going to live in this country or in this land where I have that freedom, where I don't have the freedom to do certain things. Yes, it's important, right? I choose to live in a place where I agree to give up some of my freedoms, as opposed to some other place where, I don't have that constraint, right? I can be free to do whatever the fuck I want, right? So, but we willingly choose to do that. Why? Because, that sacrifice buys us something that's even better, right? So when you have a foresight to think that, anarchy is not the way to go, because in anarchy, I'm not ever going to be able to enjoy myself, right? I can't sit down and chill, right? I can't be happy on my own, right? All of that is predicated on the fact that you can be happy on your own, right? If you can't be happy on your own, you're basically screwed at that point, right? So once you figured out a way in which you can be happy on your own, you basically want to say, well, I'm basically willing to give up all these freedoms. I don't care, because those freedoms buy me things but that I don't need. But by giving up all those freedoms, I get something that's even more valuable, right? So you say, I want democracy. I want democracy where, I give up all these freedoms. I have, the police and the law, as long as they're legal and doing the right, fair thing. Okay, that's why it's very important for us to vote next month. So it's very important to vote and exercise your vote in a democracy, because that's a freedom. And you're saying, I want this freedom so that, I can give away some of these other freedoms so that I can enjoy the life of security, and, so that the government says, here, I'll give you a social security check, enough to just keep you happy, right? And as long as you don't mess with other people, we'll take care of you. So that's the country I want, and that's where I'm going to. So likewise in C++, say I want the freedom. I want to give up the freedom that C gave me, so that I have the compiler looking out for me. How does it look out for you? Because this is a saying. I think there was a saying that in C, you can shoot yourself in the foot, right? But if you're doing the wrong things, you can shoot yourself in the foot. Whereas in C, you can shoot yourself in the foot and blow the whole leg off. I don't know. I'm probably screwing up the whole joke, right? Got to look it up. But that's how it is, right? So you want the security, because when you have security, I find that people can be their most creative, right? See, everybody wants to be creative, right? Everybody wants to be doing new things and making beautiful things, but you can only do that if you have security, right? And so all these big companies, right? They make sure that you're taken care of, right? Food, all your basic necessities, right? Taken care of, and so that you can just focus on what you love doing, right? And then C++ says, I'll give you a compiler that will make sure that you don't go into the dangerous areas of the C++ landscape, this jungle called C++. You're not going to go into the dangerous areas. You can if you want. Right? That's the beauty of C++. You can go into the dangerous areas if you want. But C++ says, here's a trail. Here's a trail through the landscape of C, right? That is known to be reasonably safe. Right? So if you go on this trail only in this jungle, you'll see all these beautiful creatures, right? You won't see this fangs tiger, but you'll see all these, other nice animals. And then you play with them, an elephant and a swan and things like that. So do that. But if you step out, you go into the wildies, you're going to get killed. Right? Well, no, you're not going to get killed. But if you step into the wildies and you don't know what you're doing, okay? So you step in the wildies without a torch or, or without lights or you're basically screwed, right? So that's basically what C++ is. You give up the freedom so that you get something of greater value back. And so where were we going with this? Oh yeah. In terms of the convention is that it doesn't matter to the compiler. I can have an integer variable and call it x, right? But find out what the conventions are for variable naming. And I would say that if you have an integer variable, your preference should be, don't call it x. Right? So choosing variable names, believe it or not, takes a good chunk of your time. Right? When you get to heavy-duty programming, choosing names takes a lot of time. Not bad time. Sometimes it's a pleasurable experience, but still, you have to be careful there. So why do I say that? Because for mathematicians, computer science is really a field of mathematics. right? Because mathematics is a science too, right? But not an empirical science. But computer science is in that sense, it is both a theoretical as well as an empirical science, right? You can have these mathematical ideas that you can verify using empirical tests. And of course, with empirical tests, you can never have 100% certainty, right? But still, computer science, you can do that. It's like mathematical induction. Anyway, where was I going with that? So yeah, so mathematicians and computer science, x is, well, what kind of variable is x? Is it a discrete valued variable? No, right? Because for discrete variables, we don't say x in mathematics. We say n, m, I, j, k. Yeah. Okay. So those are typically matrix. If you're doing linear algebra, right? AI. Aij is a matrix cell, right? So I use ijk for integers, and then use x, y, z for reals, right? So floating point numbers. So that's a convention. Now, you don't have to follow the convention, obviously, right? Because I can write a program that just says int x, and it'll work because the compiler doesn't give a shit about that. But a fellow programmer will. Right? And 5 years later, you come back and read your own program. But 5 years later, you would have changed, right? I bet you would have changed if you're using X now, because you're going to be coding. You're going to be reading a lot of code written by other programmers. You'll see that, this convention is what's being followed everywhere. And it's, I can make it easier for myself. I also follow that convention. You're going to follow the convention, and pretty soon you'll forget that you use X, and you go back and read your program from 10 years ago, and you use X. You say, what a stupid dumbass, use X for, right? This is making it harder. It's not that it makes it harder, but you take a millisecond more to read that program, right? You may think that a millisecond doesn't matter, but you have a lot of these. I said that before, right? It's like driving along on a highway at 100 miles an hour and then hitting the brake every 10 seconds, right? And then you don't really want that. Not driving to complete stop, but that hiccup that gets really painful after a while. And you say, no, I'll just follow convention so that I can just, float along. You float along, and then you can float along in the stream. And then you get the thing to work for you. Okay, so int x, so you'd say int n, right? So int n, and then where's it going with this? Okay, so you write a program, and then you can add, create values there, add it, subtract, and print it. All those things can be done right there. Now, at this point, since we have more than a half hour, it's entirely up to you guys. So you tell me what you want to code, or even better, why don't one of you share the code, and you can start coding, okay? And I'll just be an onlooker, right? And you guys can code and also chat with each other in the Zoom window, or even verbally, and I can listen in and look at what you guys are doing, and that would be an option too. So, but that's all we want to do today. I don't want to do more, right? Because it's important, I think, during the first few sessions of any skill that you're trying to learn, to go really, really slow, okay? Even if you manage to cover a lot of material during the early stages, I think it's important to stop, okay? Stop, and then don't do any more. Talk about other things, talk about squirrels in your garden or whatever it is, right? So don't, because I think that some of these heavy duty concepts need time to sink, right? So you're pouring water on the ground, it takes a while for all the water to sink into the ground. So take a little time, and let's just go over the same steps, everything we've done so far. Maybe you want to do expressions and addition, subtraction, multiplication, play around with plus, minus, and all the other different kind of operators. Yeah, that's an interesting experiment, right? And our motto is, when in doubt. Well, actually, that's not true, right? What did I say in the Reddit? I think I came up with something else after that. When in doubt. Yeah, actually it is. When in doubt, try it out. If you still don't get it, then hit our subreddit. Yeah, I think that's it. That's a yeah. Okay, all right. So when in doubt, try it out. Okay, so thank you, Giorgio. Okay, so just go ahead, try it out. Open up a screen and ask us to share the, share your screen, and then everybody will be able to see what you do, right? And go ahead and type it. Or if you want me to type it, one of you will have to switch off your mute and talk me through it, right? I'm not going to type anything here unless you tell me what to type, all right? So how about this? Yeah, that's really cool, right? So I'm just going to be your robot keyboard here, okay? I'm going to be a robot keyboard. One of you volunteer maybe, okay? You're going to think up a program. Take 5 minutes. Take 5 minutes. Maybe I'll go, drink some water. Right? So take 5 minutes to confer amongst yourself. Think of a, it shouldn't be a complex program with loops and if statements. No. Okay. So the only thing you're allowed to play around with today is expressions, right? And see out, see in, reading input, and so on and so forth. Oh yeah, reading input. And I think I'm pretty sure we had a video recorded from a previous quarter. It's out there, right? When you're reading input, don't professionally, right? So when you're doing some real programming, don't do this, okay? I want to read an integer from the user. I'm going to do this, okay? It'll work, but don't do it. And there is a good reason for that, right? Well, in two reasons. Interface-wise, first of all, you shouldn't do this. You shouldn't just read without telling the user to type something in, right? So if I run this program, it's just going to hang. Well, it's not hanging. It's actually waiting for me to type an integer, right? If I run this, right? Oh, geez, okay, I got to use namespace, okay? Or I either have to say std : here, or alternately, I can tell the compiler, I'm going to use a lot of variables in this namespace, right? So prefix every variable that I have. If you don't find it locally, prefix it with that, right? So I can get that effect by saying using namespace, right? So if I do that, then I don't have to do std : right? So if I run this, okay, I should get into the habit of looking at the screen, right, when I'm typing, because there's a lag. There's definitely a lag. Okay. All right. So it looks like the program is not doing anything at all now, but actually it's waiting for my input. So I can say 6 and hit enter. Then the program is finished. Okay. So see exit code 0, normal termination here. Right? But how do I know? How does the user know that the program is waiting for them to enter? So you always, right? So you always program from the user's perspective. Think about what the user wants, and then if you're expecting the user to do something, tell him, right? Because you're a programmer and you don't know what to do. How does a user who doesn't even know how to use computers, knows how to use computers, doesn't know programming? So you have to give the user a prompt, okay? So enter a number, okay? And then hit a colon. What I do, obviously you don't have to, is, whenever I issue a prompt to the user, I do 2 things, right? Keep this in mind. You don't, obviously, right? So after the colon, I always put a space, right? And the reason is because when you run this program, let's do this, right? We're gonna run this program, right? And you'll see that the prompt is printed, and then my number is going to be, just to see the cursor is right up against there, right? If I want to type a number there, it doesn't look so pretty, right? So put a space, because number is a different word than the number. The number itself is different from the number word, right? So put a space there. So the way, think about when you're coding, always visualize what the user will see. Right, and then try to make adjustments and finesse it such that the user has a good experience, right? Because you're also going to be a user, so if you make it easy for them, it'll be easy for you. Okay, so let me stop that here. Let me stop this. What I want to do is put a space there, and the other thing I do is I don't do an endl. Okay, a lot of people do this, and I've also seen, once I used Zybooks for my classes, and the example programs in Zybooks were also using this endl at the end. Don't do this, okay? If I do this, then what happens is that the prompt will be on a certain line, and then it accepts input on the next line, which is totally counterintuitive for me, right? Because if you think about how you've been using computers, it's not like you were, every time you had to enter information, you were entering it on the same line as a prompt. You're not going to the next line. That's all a bit of a pain, right? So what I do is this. And where was I really going with this, right? When you are right? When you are reading in an integer from the user, anytime you're reading in anything other than a single word, okay, and you know that it is a single word, that's the important thing. You got to know it's a single word, right? You shouldn't use cin double greater than. Why do I say that? There's a reason. You can look it up. It's mainly because cin, it boils down to thinking about your product from a user's perspective, because so when I type something here, a whole bunch of stuff, right? And I hit enter, from my perspective as a user from my perspective, right? This whole thing, everything I entered has been transmitted to you and you've read it, right? But if you use cin, you're only reading the first part, right? You're only reading, because cin is designed by default to stop at white space. So even though it got the whole line, or you typed the whole line, the cin only read this. Okay, and there's an unfortunate side effect, consequence of this is that this is now this part, the second part of your input hasn't disappeared, right? It's still there. It's waiting in the pipe, right? So when you type something in, there's an invisible pipe that goes to your program, and then in this pipe you got two words, and cin only took the first word. The second word is still there in the pipe. So if I have many different cin statements and the user is supposed to type one word there and so on and so forth, right? And they ended up typing all the words in the first line. They all went in. And then maybe next you're going to type, you ask the user for an integer, right? But then the first prompt asked them to type a word, and they typed in two words, right? And the first word got read, and the second word is still there, and it's not an integer. And the next time you're going to read an integer, you say enter an integer, but cin is going to go and say, I'm going to get the next thing from the pipe, and it's going to be an integer, and you'll get it. It's not an integer. It's a word. And then, it's going to say, oh my gosh, this pipe, I wanted to read an integer, but it gave me a word. So obviously something's wrong with this pipe. I'm going to stay away from it. And it'll shut the door on that pipe and never use it again until someone goes and clears the bad bit. There's a bad bit, right? So they have to say, okay, this pipe has been repaired and fixed and it's clean now. You can read from it again. Until then, cin will basically fail. Right? It won't be able to read it. Now, it's not even that much of a problem if you're the only user of cin, right? But that's not the case. In a distributed environment, you're developing a project with multiple people, right? cin is actually a global resource, right? Multiple programmers working on the same project, they're using cin. Now, if you go in and basically try and read some, crazy shit from the pipe, and it's not set up to do that, and it's your fault, right? You're trying to read an integer, right? And then you thought, well, cin is, and then cin, and you shut down cin. You shut down cin for everybody in that program, right? So you screwed up a global resource by doing something bad. So my recommendation has always, this is what I follow anyway, right? So maybe you don't, right? And it served me well. My recommendation is that when you are trying to read from cin, always try and read what the user thinks they sent you, right? Never try and read what you think you want from the user, because the user is thinking something completely different most of the time. We never know what other people are thinking, right? So you can make some good guesses, maybe, or bad guesses. Who the hell knows, right? So you don't know what the user is thinking. So don't try and say, well, so read the whole thing. So user gives you a whole line of 5,000 words. When you only ask for one word, read the whole damn thing, okay? Read the whole damn thing, because the user thinks, as far as they're concerned, they sent you the whole thing, right? So next time you ask the user something, you want them to enter something brand new, not something they entered before and it's still there in the pipe, not read, okay? And especially true if the data types are all are changing. So you got to make sure that so that's why I say, whenever you want to get user input, get the whole line and not as an integer, because maybe the user typed a word, right? What is the most general form of input a user could give you? It's a string, right? So always read the entire string. And there is a function in C++ and C2, right, which lets you read an entire string, and that function is getLine, okay? I gotta stop this. Okay, so there's a function called getLine. So the getLine will read everything the user sent you, right? From the beginning until the new line, until they hit enter, everything, it'll take that and put it inside a string variable for you, okay? So I'm gonna create a string here, string user input. Okay, you use camel case, or lately I've gotten in the habit of using snake case. So, right. Okay, so I got a string called user input, and I'm going to use get line, okay, from cin into string. Oop. Okay, so that will get the input from the user and put it in. Obviously, I don't want to. I just want to. I want to insert a prompt there, right? Actually, let me just use these keys. Ah, geez, it doesn't. Not all Emacs things work. Okay, I gotta cut this and put it here. Yeah. Oh, but you get the point, right? All right. All right. So now I can get the entire string. Now, but the challenge here is now I want a number, but the user entered a string, right? So how do I get the number from the string? I'm not going to go into the details. You would use something called iString stream. Now, because the reason I'm not going to go into this here is because we've done a pretty good job. Right? Michael's modules for accepting user inputs, I don't think anyone can do something better than that, really. Because you can try it out, right? So you can try it out, and wow, why is that C capitalized? What? Oh. Okay, right? So read the entire string and then use iString stream. And you can ask me later, what time is it now? 9:32. Damn, time just flies. Right? So you can ask me what iString stream is. What's the out? What is the in? What is the out? What is iString stream? Well, and these things. So iString stream, right? Well, might as well talk about it. It'll probably take 2 minutes. All right, so here I got the string, and now remember what I said before was, what we don't want to do is to screw up a global resource, right? I don't want to read an integer from cin, which is a global resource, because I might screw it up for everybody because it's global. Now, however, if I had my own resource, right, my own personal resource, I don't care. I can screw it up because it's not going to screw it up for other people. But or at least I know, right? So what I want is something that is equivalent to cin, meaning it is also a stream. It's a stream is a pipe, right? A stream is a pipe. So I want another cin. Yeah, that's basically what it is. I want another cin that I can play around with, and I can mess up, and other people are not going to be affected, except that this is a special cin. The original cin, the pipe was connected to what? My end of the pipe was connected to what? Yeah, my cin. Are you guys still there? I got it. Oh yeah, okay. All right, Augie. All right. Where did I get the chat window? No, let's not waste time. All right. So the cin is connected to my keyboard. But the system cin. But my special version of cin, I want to connect not to the keyboard, but that end of it, I want to disconnect from the keyboard and connect it to a string that I have. Right. So it's freaky, isn't it? Now I got a string in memory. The string is basically just lots of characters, right? Lots of characters, one after another, right? Bum, 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 like that, okay? So there's a string I've stored in my computer's memory somewhere, and I'm going to manufacture a brand new stream, which is going to behave exactly like cin, except that this stream is connected to that string. So every time I read from the string, this stream, this pipe, I'm not reading from the keyboard, I'm reading from that string, right? So that's how it works, right? So if I go, this keyboard, okay. So I could say, give me a string, iString stream, right? So this, you'll pretty soon know the syntax for, what these things mean now, right? So I'm going to say iString stream, space, I'm going to call it IS, right? Although it's an English word. because it's a short program, right? Input stream, IS. I string stream is input string stream, IS. And I want to manufacture that input stream using the input the user just gave me, right? CN. Oh, you guys should correct me when I'm, this should not be string. This should be user input. This is what I want. I usually have a comma before, a space after the comma and so on, right? It's better. Okay, so CN user. So I want to take that user input and manufacture a stream with that. So this is how I do it. I say user. Okay, now I've got a stream. Now from the stream, instead of doing CN greater than N, I could basically say IS greater than N. Okay. Now, what happened to me? Indentation there. Okay. All right. So now I'm reading from a stream, except it's not CN. And so now if the user had entered a string, it's going to, screw up my stream. So my program will fail and crash. Obviously, if the user entered bad input, but because, maybe I'm expecting the actual value, not the default 0 that you'll get if the user entered a string, right? And the stream will get marked bad too, but at least it's my own, right? So you only ever use CN double greater than if you're reading from a source from which the data format to be 100% predictable, right? When is that? You will have many situations in which later on you would read from a source, a stream, in which the exact format in which the data is going to be stored. Unless you know the exact format, never ever read. Don't take it for granted. Don't assume that the input is going to be a particular data type, because if you do that, you're basically screwed at that point. Because this is a whole bunch of people that may be supplying. So what was it going that? So take the user input in a string form and then read from it, and then from here you can use individual. So even if the user, even if you're expecting text input, right? Even if you're expecting text input, get the whole string. Get the whole string and read from that. Read word by, because CN will only get one word at a time. If there's a space, it'll stop there and leave the rest in the pipe. So, but that's not what the user thinks, right? The user thinks they gave you the whole thing. So always keep the user in mind, right? Does that make sense? All right, okay. So why don't you guys take 5 minutes or so and come up with something to code for the next, I don't know, got 20 minutes more, okay? 25 minutes more than 25 minutes, right? So yeah, come up with something that you want to do here. So how about you guys ask the user, oh yeah, this is what we wanted to do, right? We wanted to convert a number from decimal to binary using this, okay, without using loops and all. So let me see. So let's say let me do this, right? Okay, let me do this. Probably take me 2 minutes. Okay, all right. So I'm gonna do this. Let me get that back because I wanna. Okay. So and then a prompt. Okay. Enter a number, and I'm gonna say to convert to base 2, right? To convert. Okay. Now I've got the number here. Oh, and then in order to use iString stream, you got to include this file. Right? This is where iString stream is, defined or declared for you, so that when you use it, the compiler knows. Oh yeah, okay, that's what they mean, right? Okay, so iString stream, I got this, and then I'm going to say IS N. Okay, now I want to convert N to binary. All right, how do I convert that to binary? So, and I'm not going to use a loop or anything here, okay? So I'm just going to keep everything really, really simple. So what do we do in binary? Just keep dividing by 2 and taking the remainder. Yes, this is what we do, isn't it? Keep dividing by 2 and take the remainder. Okay, it's 9:40. So we got 15 minutes. All right, Augie, it's 9:40. You got 15 minutes, at least 15 minutes, right? Because you only got, we're going to take 5-minute breaks because it's an online class. Okay, so thank you for reminding me. Thank you. Yeah, okay. And don't say it's 9:40. Say, you know, talk about talk about the important stuff. Don't talk about riffraff. You know, not really, waffly things. Okay, so convert into binary. Well, we'll keep dividing by 2. Take the reminder. So I'm going to say int let's say quotient, right? And remainder. Okay, now I'm going to calculate the quotient and remainder like 5 times. Let's assume the number is no bigger than, well, let's say 8 times. Okay, 8 times. Now, let's assume the number is no bigger than 8 bits. Okay, so I'm going to do this and then I copy and paste it 8 times. Okay, so let's see, quotient equals n divided by 2. Yeah, is that right? Now, it's very important. If I say, if it's very important that n is of type integer, okay, and the 2 is, you know, quotient is of type integer too, right? Because otherwise you'll end up with fractional numbers in there. So you want the integer part of it. That's the quotient, okay? N over 2. Remainder. How do I get the remainder of dividing n by 2? It's on the subreddit, so we've already done this. Okay, all right. So we don't have to do this, okay? So if you guys know how to do this, we don't have to. Oh, okay.
Referring to
all right, okay. Well, we'll do it. It's not going to take a lot of time. Okay. So how do I get the remainder? Someone tell me how do we get the remainder? Divide by 2. Hey guys, talk about this modulo 1 YouTube stuff later, okay? You only got 15 minutes. You got to focus on the class. Focus on the class now. All right. So yeah. Tell me, how do you get the remainder after dividing by 2? Right. So this is called the modulo operator. Okay, this is called the modulo operator. Yes, thank you, Momo. All right, so the modulo operator. If I use that, it means divide and give me the remainder. Okay, so now I've got the quotient, I've got the remainder. Now all I need to do is basically say, you know, I don't care about the quotient because I'm just going to use the quotient one more time, but I want the remainder, so I'm going to say cout remainder, right? And notice that I'm not printing a space. Yeah, I'm not printing a space or anything. I'm just printing the remainder only. Okay, so I'll get a 1 or a 0, 1 or a 0. And no new lines either, okay? No new lines at the end. So I'm going to do this. And now I'm going to do this 8 times, okay? And notice that, you know, I may do the cout. It's not going to come out. I'm going to do it 8 times. So this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I got it 8 times. Now I can print a cout new line. Okay, now if I run this program, it'll ask me for a number and it'll convert that to binary. It'll convert that to binary and then it'll print it out, except that the order of the digits might not be what you expect, right? Now, in order to get the right order of the digits, you have to print the numbers in the other. Actually, is that true? Yeah, you got to print the number. So it's going to be inverted. It's going to be inverted. You can try it out and see what happens, okay? So run that. Yeah, that's what I don't like about cpp.sh. Sometimes it's, oh yeah, thank you, man. Who was that? Augie. Yeah, there's a bug in my code. All right. Oh, cancel this. Okay. Thank you, Augie. All right. I don't know if you guys saw Augie's comment. Okay. So what you want to do is basically say quotient over 2, and you know, gee, I got to do this. I'll just do copy paste. Okay. And then quotient. The quotient is what keeps changing each time. Is that right, Augie? You guys can probably do it a whole lot faster on, because it's slower for me because I'm looking at this screen and programming in that screen. Okay. Even then, I think this magic trackpad has got to be configured correctly. I don't know if I've got it right yet. Oh, maybe my other.
Be careful, on line 31, you have an extra N after quotient.
Where is it? Line
31.
31. Oh, thank you. Thank you. Okay. You know what would have been easier is if I just done one and then replaced all the other ones, which is a copy paste.
Line 47 as well.
47. Okay, I'll come to that in a sec. 47. Yeah. Is that right? Okay, so let's run it. Yeah, that's what I don't like about it. Sometimes you don't know. So when that happens, what I do is I just make sure I have this in my clipboard because I don't want to use it, lose it. So I have it in my clipboard, and then I reload. So I go to a different CPP SH server somewhere else, maybe. I don't know where their servers are. But now I go, oh, it's still loading. It's why is it loading? Am I connected to the network? Right. Yeah, you know, it's just not. Sometimes it's not us. It's them. Yeah, I don't. Maybe I just copy the whole thing into Replete. I got it in my clipboard. Okay, so start coding. You know, I've never used Replete before, so let's see. But I know that it's there. Create. Yeah. Okay. Okay, so let's say Command A, Command V. Okay, now how do I run this? How do I run this? Hey, oh, there it is, the run button. Oh, you actually get a, oh, I redefined quotient. Oh, geez, int. I only need the first one. So, I mean, you basically declare the variables, but only once, right? Is that it? Got everything? No, one more. Okay, run this.
Line 45.
Oh, thank you.
Also, for indentation purposes, does line 54 need an extra space?
Where is 54? Is it off? Oh yeah, it is off. Why did it do that? Is it off here too? No, it's not off here. You see, it's not off in my
It was off when you first typed it on the other
yeah, okay. All right.
interface.
That's why. Thank you. All right. So run this. Okay. Now enter a number to convert. Let's take a number for which we already know the binary representation. 12. Yes, it's 12. So what is the binary representation of 12? We did it in last class.
1100.
1100. So we're supposed to get 1100000 if I. Oh, geez, I can't. Yeah, I can. So we were supposed to get 11. Actually, we're supposed to get 00001100, right? Yeah, actually, Augie. In fact, what we would get is maybe not even 0011. Let's try it, okay? So I'm going to hit enter, 12, and enter, and I get 0. What the hell is that's not right? Well, so there's a bug in my code, right? So obviously there's a bug here because we need to have 4 zeros. So if you look at the program, the way it does it is get the last digit. Last digit. What's the last digit? 1100. 0, 0. Okay. Well, okay. All right. So I don't want to waste the rest of the time. We only got like 5 more minutes, right? I don't. So you guys figure out what the hell is wrong here. You know what the behavior is. You know what the desired behavior is. It should basically print 00001100, right? So that's what it should print. Actually, it should print 1100 and then 0000. Actually, no, it should print 0011 0000. Yes, that's what it should print. 0011 Yeah, 0, 0, 0, 0. That's what it should print. If we do this in our head. So I think the first 0 is missing for some reason. And what's going on? So quotient, you can, step through it and find out. It's just that we don't have time. But we can do it. We can do it on, Thursday. Is it Thursday already? Yeah, okay, all right. We can do it in a different class, later. The bug has to do with it being backward as well as one space. Okay. 0, 0, 0, 0. But I should only have 4 zeros at the end. So one, yeah. Well, I got to think through the logic. I'm not able to do it right here because we're also on a time crunch. But you can. It's pretty easy to figure out, right? So it's some obvious mistake in my code. So here's a challenge for you, right? Figure out what the bug is, and then fix the bug, and then share the code. Share the code in the forums. You set quotient to n over 2, remainder to n% 2, then divide the quotient by 2 again, divided by 4, and take, so it skips the 2 places, 2's placed. Oh, thank you so much. Okay, quotient should just be equal to n. There you go. Who said that? Augie. Oh, when? And Augie, all of you guys, okay? So, all right, so there you go. Quotient should be n. I set it to n over 2, all right? So now it should be fine. If I run it, I think I should get the answer that we want, okay? So 12, there you go. So 0, 0, 1, 1, 0, 0, 0. All right, so does that make sense? Okay, all right, so that is basically it. And if you have any questions, I can talk about it. Or else you guys could feel free to ask me to come back and do some other program here, or you should just feel free to knock out one more program amongst yourself in Zoom, right, in a shared screen before you go on to the to your next class. Does that all make sense? Now that it's all online, we should have longer lectures rather than 2-hour classes. And that way, especially for programming, right? Because in programming, you're basically spending a lot of time just getting into the thing, the mindset. And then once you get in the mindset, you're on a roll, right? You just want to keep going as long as you can, right? Okay, so this is it. Are you guys okay? So we wrote our first program today. Did you guys get any useful information out of this, or basically all the stuff you already knew? Maybe it's if it's all stuff that you already knew, that's fine, because pretty soon we'll get to a place where we'll start talking about newer and newer stuff. But there are people, I hope that for whom this was useful. Okay, so please chime in if that is true, so that I can tweak the lectures and do it the right way. But I think I covered what I wanted to do for your homework. For what you want to do later. Great, thank you. So things you can do is try and figure out what plus plus is. There's 2 operators we didn't cover, okay? But I don't want to cover now. Really for you to discover. Minus, minus. These are special operators, okay? You have other binary operators. These 2 are not binary operators, by the way. They're unary operators. Unary means it only takes 1 parameter, right? Binary takes 2 parameters. Like to binary operators, I can say something like, 2 plus 5. Plus is a binary operator, takes 2 parameters, 2 on this side and 5 on that side, right? But a unary operator takes only 1 parameter. So a plus plus and minus minus, or even just a minus 5, right? Minus 5, right? Minus is a unary operator that takes the value of the variable or constant, right? Minus x, and then negates it. Negates it. If x is negative, it makes it positive. If f is positive, it makes it negative, and so on, right? Try and figure out what plus plus and minus minus are, and it's very important. This is a very subtle distinction among the different ways in which they work. Okay, they both end up incrementing and decrementing values, but there's a slight subtle difference. You got to find out what it is, because that difference is going to be so key. Right? It's going to be so key to everything you're going to do later on, right? You're going to be writing loops and things like that. You'll be using the plus plus and minus and operator. These 2 operators are so incredibly useful that ever since C++ came up with invented these 2 operators, every single language I know, right? Most languages I know use these 2 operators, right? Java, Python, JavaScript, many languages. They use the same operators with the exact same semantics and the syntax, right? So they're powerful efficient, like super duper efficient operators, right? And it's good to know. It's good to know. These two operators you should always have in your pocket, right? And good to go from there. Is that good? Everybody all right so far? Okay. Well, anyway, I'm done. I'll leave the Zoom session on for a couple of minutes, maybe, and then I'll shut it down. But feel free to congregate, and play around until you guys need to go to your next class. Okay. Otherwise, I'll see you on Tuesday. If you need me to talk about something else at other times, just send me an email. If a sufficient number of people are interested, I'm very happy to schedule a time. Okay. Because even today we had a meeting at 1:30 that got canceled. So I still have a floating 2-hour block that I can use for anything you want. Okay. So, all right, Giorgio, good luck with your math test. Okay. So take off, and then we'll talk to you later. All right. Thank you. See you guys later. Maybe I'll shut it off. I'll shut off the meeting now. Okay. And then.
But before everyone goes, Andrew and I were thinking about creating another Zoom call just to
Yeah. Go for it. Go for it. Okay.
like a study session.
Yeah, I'll leave the window open.
If you guys
so
want to
go
join.
ahead, create your call, share the information you want, and then I'll come back in a few minutes and I'll, shut down the live stream. Okay? All right. Thank you, guys.
Yeah, so Andy and I will post this in the subreddit in case you missed the link, but we figured it might be helpful to just do a troubleshooting session on kind of how to jump into coding. If anyone is still having questions, we're happy to help out.
All right, good. So can I close the window?
Yeah.
All right, good talking to you guys today. All right, talk to you on Tuesday. Have a good weekend.
Thanks, Professor.